The towering peaks of the Andes have always felt eternal, guardians of an ancient past, home to mighty civilizations like the Inca and their mysterious predecessors. But who were the first people to settle these highlands, where thin air and brutal cold made survival nearly impossible? Were they just lowland foragers who slowly adapted over generations? Or was there another story, one that begins far away? New ancient DNA evidence is turning this narrative upside down. It reveals that the earliest highlanders may not have been who we thought, and their journey into the clouds was more complex than archaeology alone could ever show. Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. Stretching over 7,000 kilometers along South America's spine, the Andes are the longest continental mountain range on Earth. Within them lie the high-altitude plateaus and valleys of Peru, Bolivia, and Ecuador, regions that sit above 2,500 meters where oxygen is scarce and weather is extreme. Traditionally, archaeologists believe that humans moved gradually into these heights, after first settling coastal and lowland regions, following their arrival in the Americas around 15,000 years ago. The theory held that groups of hunter-gatherers slowly adapted to altitude through generations of exposure. Around 9,000 years ago, permanent highland occupation began, followed by the domestication of native crops like quinoa and potatoes and the eventual rise of early states. From this perspective, the Andes were a challenging environment conquered over time by resilient local populations. But despite the coherence of this model, the evidence was largely circumstantial, based on artifacts and bones. The genetic legacy of those first highlanders had yet to speak. Archaeologists began to notice strange inconsistencies in the Andean record. Some high-altitude settlements dated earlier than expected, with signs of permanent occupation above 4,000 meters as early as 9,000 years ago. These sites contained domesticated crops, complex toolkits, and even cranial modifications, suggesting a sophisticated culture, not just struggling pioneers. But how had these early people survived such extreme environments without centuries of gradual adaptation? Modern Andean populations carry unique genetic traits, especially variants in genes like EPS1 and EGLN1, that help their bodies cope with low oxygen. These traits were thought to have evolved slowly over time. But recent skeletal and cultural clues hinted at the possibility that some early Andean groups may have already possessed high-altitude adaptations, or may have developed them rapidly through intense selection. These cultural markers, combined with emerging genomic data, began to challenge the view of a slow, local evolution and raised a bigger question. Who were the first to call the high Andes home? To unlock these mysteries, scientists turned to ancient DNA extracted from skeletal remains found in highland burials across Peru, Bolivia, and Ecuador. The individuals ranged from around 9,000 to 2,000 years old and came from a variety of sites: rock shelters, cave burials, and early village cemeteries. Researchers used state-of-the-art methods like hybridization capture and high-throughput sequencing to recover genome-wide data from teeth and the dense petrous part of the skull, which protects DNA even in harsh mountain conditions. Once the DNA was sequenced, scientists compared these ancient genomes to both modern populations and other ancient groups from across South America. They searched for signals of genetic continuity, unique adaptations, and signs of admixture. What emerged was not a single evolutionary line moving slowly upward into the mountains. Instead, the DNA revealed a more layered and surprising history, one involving multiple distinct groups, each playing a role in shaping the human story of the high Andes. The ancient DNA revealed something unexpected. Some of the earliest individuals living in the high Andes carried genetic lineages not commonly found in today's Andean populations. These early settlers, dating as far back as 9,000 years ago, showed affinities with distant groups, including those from the Amazon basin and even farther north, suggesting they weren't simply lowlanders who gradually moved uphill. Instead, they may have arrived already carrying traits that helped them survive at altitude, or they developed them rapidly through intense selection. These lineages appeared to diverge from other South American populations earlier than anticipated, indicating a long and separate trajectory of evolution. Moreover, they lacked some of the high-altitude adaptation genes seen in modern Andeans, hinting at alternative physiological strategies or lifestyles. Later individuals, those from 4,000 years ago and onward, began to show more genetic similarities to modern highland people, suggesting a second major wave of migration or population replacement in the Andes. The genetic findings led researchers to propose a new model of Andean settlement involving multiple, distinct waves of migration into the highlands. The first wave likely consisted of small groups entering the Andes from the eastern lowlands or the northern interior of South America as early as 12,000 years ago. These pioneering communities established footholds in high-altitude zones, perhaps aided by cultural adaptations or modest genetic traits that eased their transition into thin air. Then, around 6,000 to 4,000 years ago, a second major wave arrived, this time carrying gene variants known to support oxygen regulation and high-altitude endurance. These newcomers either merged with or replaced earlier groups, and their descendants eventually formed the backbone of the Andean populations known today. This model of layered migration and adaptation explains the presence of distinct genetic lineages, cultural variation in early highland sites, and the eventual dominance of high-altitude adaptation genes. It reframes the Andes not as a passive cradle, but as a dynamic frontier shaped by movement and survival. The archaeological and genetic evidence together highlight striking differences between these waves of early highlanders. The first groups, though successful at high elevations, practiced different burial customs and displayed distinct cranial shapes, some showing deliberate elongation, others not. Their diets focused more on wild plants and game, while later populations relied heavily on domesticated crops like potatoes and quinoa. Genetic studies show these groups remained largely isolated for centuries, with limited interbreeding. Only after the arrival of later migrants do we begin to see signs of admixture, shared cultural practices, and the rise of more centralized communities, setting the stage for Andean civilizations to come. The uniparental DNA markers, those inherited solely from mothers or fathers, paint a complementary picture. Early highland individuals often carried rare mitochondrial DNA haplogroups like B2A and C4, which are uncommon in later Andean populations. Their Y chromosome lineages, particularly Q2A, also appeared isolated from the dominant QM3 type found in most indigenous South Americans today. Over time, as newer populations moved into the Andes, these rarer haplogroups declined, replaced by the more common maternal A2 and B2 and paternal QM3 lineages. This shift supports the idea of population turnover or admixture events that gradually transformed the genetic makeup of the Andean highlands. These findings compel a complete rethinking of how the Andes were first settled. Rather than imagining a single group of local foragers slowly adapting to high-altitude life, the evidence now points to a layered story of arrival, persistence, and eventual replacement. The earliest inhabitants were bold pioneers, likely arriving from regions far beyond the Andes, adapting in unique ways to extreme environments and establishing the region's first highland settlements. But they weren't alone forever. Later waves of migrants brought not only new genetic traits, but new tools, crops, and ideas that would shape Andean culture for millennia. Some of these incoming groups carried powerful genetic adaptations to altitude, traits that still define modern Andean physiology today. The Andes, once thought to be a static backdrop for human innovation, now appear as a frontier zone, an evolutionary crossroads where humans didn't just survive, but continually reshaped who they were through movement, merging, and reinvention. While ancient DNA has revealed unexpected layers of Andean prehistory, it also raises new questions. Were there even earlier highland populations whose remains we haven't yet found? Did some groups migrate from the Amazon, bringing not just genes but plants, ideas, and technologies? Researchers are now seeking older remains, especially in marginal or higher altitude sites, to better trace these hidden movements. There's also growing interest in identifying how fast genetic adaptations to altitude took hold, and whether gene flow from now extinct populations played a role. The Andes hold many secrets, and each excavation and genome adds another line to this evolving human epic. The soaring landscapes of the Andes have always inspired awe, but now they also invite a re-examination of our assumptions. Ancient DNA shows us that the first people to settle these mountains weren't who we thought. They came from diverse regions, adapted in different ways, and left behind genetic and cultural legacies that still echo today. It's a reminder that human history is rarely linear or simple. The Andes were not just survived. They were mastered by multiple waves of explorers, innovators, and communities. What other highland regions might hold untold stories beneath the soil? Share your thoughts in the comments, like and subscribe for more deep dives, and check out the Patreon to support future episodes.